Go and take out your textbooks now, if you would, please. Turn to page 568. Let's get back to our end-of-year review as we get you ready for 9th grade Algebra 1 next year. Some of you watching on YouTube, you may be getting ready for a final exam coming up as well. We want to get ready for that. My encouragement to you was to look over your units last night and to look over the what's it called? Scientific notation stuff last night as well. Before we get to that, though, want to do a quick practice with signed numbers. So if you would, page 568, I want you to do numbers 75 to 86 very quickly, practicing with adding, subtracting, multiplying, and dividing signed numbers. 75 to 86. Well, I told you to write it down in your homework, right? I'm going to look at that assignment pad, Alana. Don't worry about it now, just focus on the assignment I just gave you. Page 568, 75 to 86. I'm thinking about it. Audrey is not going to be able to be here today for PE. She's got to work on some classwork, so she said that she wants you to be the captain in her absence. So, pretty much the only thing that means is you have to make sure you set the rotation when you start. That's all you really do, is figure out who's going to stand where when they start the game, and from there it's just play volleyball. So it'll be you versus your sister today. Don't let her win. Yeah, you can't do that. It's 5 and 5. His team had 6. Yeah. No, players. He has 6. You asked him because both teams now have 5 players. Is what he was asking. All right, let's take a look at our answers here. Number 75. What'd you get, Joshua? 15. 76, Lana.
264.
What? On 76?
Oh, I multiplied.
Oh, yeah, we're just adding, Joshua. We should have gotten negative 34. Okay, Lana for redemption, 77.
Negative 10.
Negative 10. Add the inverse. Good. Number 78, Joshua. Positive 3. 79, Lana.
Positive 11.
Positive 11. Number 80.
1.
81.
Negative 96.
Negative 96. Number 82.
Positive 65.
Good. Positive 65. 83.
Negative 3.
Good. 83. Number 84 is not one we memorized, but I think we get it.
Positive 6.
Positive 6. I think 90 minutes on the clock has 4 15-minute plus 2 more makes 6 15-minute sections. That's how my brain ticks at least. Clock ticks. Get it. All right. Number that wasn't planned. Number 85, Lana.
Positive 70.
Good. Positive 70. There are 4 negatives. That's an even number. So that gives you a positive, and of course you multiply it out to get 70. And then Joshua, number 86.
Negative 108.
Negative 108. 3 negatives. Odd number of negatives gives you negative, and you multiply to get the 108. Numbers 87, 88, 89. It's been a while since we looked at this idea of sequences, where you have to figure out, what rule is going on to go from one number to the next? So on number 87, you're not going to see this in Algebra 1, but you will in Algebra 2. So this is kind of, again, Something just to keep in mind for a couple of years down the road. We'll go a lot more in depth with sequences in Algebra 2. But number 87, what's the rule that appears to be followed here? -7, +8, +23.
You add 15.
You're adding 15 both times. So what would be the next
Oh.
number in the sequence?
38.
38.
Oh,
38,
yeah.
good. Look at number 88. We got a 3, a 12, a 48. What's the rule, Josh?
And multiplying by 4.
Multiplying by 4, so what's the next number, anyone?
192.
192, good, Lana. Number 89, we got a 64, an 81, a 100, a 121, and what's the rule?
You're square.
You just have squares, so what's the next number?
144.
144. Now you could look at this and say you're going up 17, then you're going up 19, then you're going up 21, so go up 23 more to get 144. But the easiest way to look at it is, hey, those are squares. All right, questions on those? All right, let's take a look at the next page there, top of the page, number 90. In algebra, what's the name for a letter used to represent an unknown value? What do we call our letters?
Wait.
Variables.
Oh.
X is the most common variable we use most of the time, right? Hence, the little puns like algebra, dear algebra, please stop asking me to find your X. It's over, let her go. Anyway,
Yeah.
stupid jokes like that. But anyway, variable. That's not on the bulletin board. All right, number 91. What is anything raised to the 0 power?
1.
1. Number 92. How would I write x squared decreased by twice z? How would I write that?
X squared minus z squared.
Well, that would be the square of z.
Whoa.
But it says twice z. What does twice z mean?
2z.
2z. Good. Twice means 2 times, right? So if Lana has 2 runs in a softball game and Josh scores twice as many runs, then he would score 4 runs, right? 2 times as many, right? Or if Glenn, hits 5 home runs in a season and Hayden hits twice as many home runs in a season, Hayden would have hit 10. Twice as many means times 2. We got some work to do for next year, buddy. Number 97, in the expression 7xz plus 13, what is the constant term? That's the variable term.
Oh, 13.
The 13. The term that only has a constant in it and no variables. So that term is always a 13, whereas depending on what x and z are, the other term could have a different value. Number 94, how many terms are in that thing?
3.
So it's a trinomial. Good. 3 terms, it's trinomial. How about number 95? 1, so it's a monomial. And 96 says, you don't have to write this down. Binomial, right? There's 2 terms. By the way, look at number 94. It's arranged in a specific order because you have the y cubed, then you have a y squared, then you have a y to the first. The powers keep getting smaller.
Decreasing.
Not decreasing, but descending order. Descending order on number 94. Number 97 says to evaluate if x is 9, y is 4. Tell you what, go ahead and do number 97, 98, 99. 97, 98, 99 very quickly. Again, make sure you follow order of operations as you evaluate. And this is all stuff that if you remember it next year in Algebra 1, piece of cake. You forget it all, have to relearn it all, Algebra 1's going to be a little tougher. But the more you can remember, if you can avoid forgetting anything, right, then it just makes every year in math so much easier. Let's see how we did on these. 97, what do we get, class? 6. Number 98 we get 1. And number 99?
Negative 12?
12.
Positive 12.
It's positive?
Yeah.
Positive 12. So when you remember when you square negative 4, you get positive 16.
Oh.
But then in the next thing, it's minus 4 times negative 4 times 2, which gives you minus negative 32. But you never subtract, you add the inverse, so you make it plus a positive 32. And that's where we get 48 divided by 4 is 12. All right, let's look across the page now at the chapter 2 portion. And this is the stuff I asked you to look over last night in preparation for today. Number 50. We're not going to do it for sake of time because we're running a little bit behind here, but how would I convert 15 teaspoons into tablespoons? Page 568. Across the page. Across. Right, you divide by 3. Divide by 3. How about then you get 5? Number 51. What would we do to convert seconds to minutes? Divide by 60 and you get 6. Number 52 is a metric problem. They give us 14,500 meters and are asking us to convert that into kilometers. There's a little saying for metric. What was it?
King Henry died unexpectedly drinking chocolate.
Yeah, King Henry died unexpectedly drinking chocolate milk. We do need to remember that this first D is actually deca. So meter, which of these would the meter be? That's the units, not the milli, it's the unit. So we start here, and we're going to kilo. So we go 1, 2, 3 places with our decimal. Where is the decimal in the number?
After the
At the end. So we move it 1, 2, 3, just like it showed us to do. What do we get?
14.5.
14.5. Do the problem 53. Let's go and convert 1,700 decigrams into hectograms. 1,700 decigrams into hectograms. And what do we get, Lana?
1.7.
Once again, we end up moving that decimal 3 places from the deci to the hecto and get 1.7. 50 hours is how many seconds? Whoa. We're going to take 2 steps here. First, we need to convert hours into minutes. Doing what?
The dimensional.
Right, but how do we go from hours to minutes?
Using the 60.
You multiply by 60,
Yeah,
right?
multiply.
But then from minutes to seconds, we have to do what again? Multiply by another 60. So 50 times 60 times 60 would end up giving us 180,000 seconds. You don't have to write that down, that's fine.
It's alright.
And then number 5, similar idea, 5 tons to ounces. Well, you can't convert directly from tons to ounces. We convert from tons into pounds, right? So how many ounces in a pound? Or, I mean, how many pounds in a ton, excuse me? 2,000, right? So we're going from big old tons to little pounds. Multiply by the 2,000, right? But then from pounds to ounces, what do we have to do? By 16 ounces in a pound. So we'll multiply there again. That kind of thing. We could use dimensional analysis as well with the fractions. Looking at 56, remember to add compound values, compound measures? You literally just add them up. You get 34 feet, 12 inches, right? But the 12 inches becomes another foot, so it ends up becoming 35 feet. Make sense? Look at the next one. We can't subtract. You cannot take 9 pecks from 6 pecks. So what do we have to do? Borrow. So we're going to make the 74 bushels 73 bushels, and we're going to take that 1 bushel and turn it into how many pecks? 4 more pecks. Now we already had 6. We're bringing 4 more over. 10 pecks. And of course, we'll subtract away the whatever it was, the 63 bushels, 9 pecks. And you do this in your head.
10 bushels of
and
1
peck.
Yeah, 10 bushels in a peck. Number 58, multiply. Remember, just multiply, right? 9 times 7 is,
63.
that's 63 ozes, and 9 times the 20 lubs, 180 lubs, right? So really straightforward, but we have to convert at the end. How many ozes in a lub? 16. So how many 16s are in 63? Almost, Glenn. 4 times 16 is 64. So we just barely missed that 4th pound. But we can take away 48 ounces, that's 3 pounds. So we'll add 3 pounds to get 183 pounds, good Glenn. And we'll subtract those 48 ounces, which are those 3 pounds from the 63 to get 15 ozes. So again, almost had that extra lub, but didn't quite make it. Remember number 59, when dividing compound numbers, you start by just dividing straight up, right? 5 goes into 37, 7 times, but there's 2 left over. But it's 2 pints. So those 2 pints have to become how many cups? How many cups in a pint? 2. So if there's 2 pints, that's 4 cups. So we had 1 cup already. The leftover pints become cups to give me a total of
6.
1 plus 4? 5.
Oh,
5 cups.
I was thinking.
Right, we had 1 cup here. We're going to add 4 more cups, gives us 5 cups. And now 5 divided into 5 gives us 1. So remember, in dividing compound values, right, just divide, but whatever's left over transitions into the other unit, combine them together, and then do your division again. Scientific notation. What is number 60 in scientific notation? Remember, it's all about how many places the decimal moves.
7.292 times 10 cubed.
Good. You'll move the decimal 2 or 3 places. It was right here. It's going to move up 1, 2, 3 places. And since you moved it 3 places, you'll say times 10 to the 3rd power 10 cubed. How about number 61?
How do you know which way to move?
You're only allowed 1 digit before the decimal.
Oh, yeah.
See, if you reviewed over like I told you last night, you would be doing fine right now. If you've done your homework, I should give her a homework offense, shouldn't I? She didn't look it over.
What?
Yeah, I told her to and she didn't. That's a homework offense, right?
The first
Yeah.
It wasn't a Wednesday, did
What?
Wasn't it a Wednesday?
It was. No homework offense. Just sheer disappointment dripping from my voice. All right, what about number 61? What do we get?
1.3 times 10 to the 5th.
Well, not times 10 to the 5th, though, because it's a little number,
Oh,
and we're going
okay.
backwards to the negative 5th.
See, I remember it.
Hey, there we go. Okay. And what about 62? Oh, this is ugly. What about 62? That's horrific.
Wow. That is very dumb.
How many places do we move the decimal?
3.
3. So we get 5.235184 times 10 cubed. How about 63? What would that be as a regular plain old number? Standard form, as the book says.
1010.
1010. Right? How about the next one? What would that be in standard form?
0.01.
0.010, or just 0.01, because we're too lazy to write the extra zeros. How about 65?
0.00020003.
Good. 0.0000, that's 4 zeros, 2003.
Yeah.
All right, number 66, remember to add scientific notation, you have to have the same exponents. So number 66, you're just fine, you just add them together, and you keep that same exponent. So we got 7.2 times 10 to the 6th, plus 1.8 times 10 to the 6th gives us
9 times
9 times 10 to the 6th. Good. What about 67? Subtracting, you have to have the same exponents, but we have them. So we just subtract to get
4.1 times 10 to the
good, 4.1 times 10 to the 8th. Now number 68 is a little bit tricky. Initially, we just subtract because we've got the same exponents to get
0.4 times.
right, 0.4 times 10 to the 6th. But remember, you have to have 1 digit before the decimal, right? So we've got to actually move the decimal backward. And since we're moving it backward, we have to drop the exponent down to a 5. So it was a little subtle thing. Now that's something that we'll look at again in Algebra 1. You'll also maybe use it in physical science when you get to that class later on in high school. Chemistry will use a lot of scientific notation. We'll revisit that in Algebra 1 next year. All right, for now, flip over to page 570. Page 570. Look at exercise 1. Just answer these together. True or false? The addition property should be used to simplify the left side of the following operation, or following equation.
Multiplication.
We should multiply, what's it called when you multiply a value into a binomial?
Oh, distributing?
Distribution, the distributive property, right. So we can't, if we could add the x and 3, we would, but you can't. So we'll call it the distributive property. Number 2. Ooh, remember those inequalities? Remember when we graphed them? You'd put like either an open circle or you put a closed dot and then you shade the arrow either greater than or less than.
Those are fun.
Yeah, so on number 2, true or false, an open dot should be used to graph the inequality x is greater than or equal to -8.
False. It should be closed.
Closed. Anytime you have the or equal to, you fill in the dot, remember. All right, number 3, when both sides of an inequality are multiplied by a fraction, the direction of the inequality symbol must be reversed. Hush, Glenn, you haven't learned this yet. This is a new thing for 8th graders. It is false. Remember, you don't flip the inequality when you multiply by a fraction. You flip the inequality when you multiply or divide by a negative. Remember, when you multiply or divide by a negative, you got to flip that around. Let's see. Number 4, the inequality 12 is greater than or equal to x is equivalent to the inequality x is less than or equal to 12. Are those the same thing?
Yes.
Yes, because the mouth is still open to the same thing and we still have the or equal to line. So as long as the mouth is open to the same thing, they're the same, doesn't matter which way you write it. Number 5, the unknown that should be represented with a variable is the one that has this is talking about in a word problem. The unknown that should be represented with a variable is the one that has the most information given about it. False. Remember when we talked about word problems, we said find the one it all comes back to in the end. The one about which you know nothing. But I didn't phrase it the same way the book did, so I'm not surprised you missed that one, because I just said, what does it all come back to? But another way of saying it is, well, we don't know anything about this. We know something about this and this. We know nothing about this. But again, I like my explanation. What's the one it all comes back to in the end? If I say Lana has $17 more than Josh, who gets to be X? Josh, because it came back to Josh in the end. In other words, I know nothing about Josh. I know something about Lana. She has $17 more, but I know nothing about Josh. Again, I like my explanation better than the book's. But that's not conceited or arrogant or anything. Drop down to the bottom there. You see those inequalities, Lana? You just said they're fun to graph. Go ahead and do those inequalities, 21, 22, 23, and 24. Go and graph those inequalities very quickly. They're on in your textbooks. Okay, sound effects people. That's my job to do sound effects, not yours. When you're the teacher, you can do sound effects and be cool. But until then, you have to be boring and dull. Kind of makes you want to be a teacher, doesn't it?
No.
Just so you can be cool and do sound effects. All right, Lana, let's take a look at this first one. We wanted to graph x is less than or equal to 4. What do I do?
You do a closed dot on 4.
All right, so there would be 4. All right.
Shade everything to the left.
Good. Shade everything to the small side, which is the left side. Okay, all the numbers that are smaller than. Good. Josh, on the next one, it says compound inequality here. -3 is less than or equal to x is less than 6. What do we need to do?
You put a closed dot at -3.
Okay, and closed dot -3.
And then an open dot at 6.
Good, an open dot or a circle around the 6.
And then shade everything in between.
Good, shade it all in between there. Good. Number 23, Josh. How would I write that inequality? What's being represented here?
5 times times.
Want to help him.
5, like this open thing to this side.
What's it called?
Greater? No, less.
Let's start with the letter X. What are all the values that are shaded? All the values shaded are all, what? Bigger than or smaller than 5?
Less.
They're all less than. So X means all the things that are shaded are all less than the 5.
Yeah.
So we say X is less than 5. Now, do we put an or equal to?
No.
No, because there's an open circle. Lana, how would we express number 24?
-3 is less than x is less than or equal to 2.
Good. You've got your two boundary values, -3 and 2, and X is everything in between, which means that all these values are bigger than the -3, not equal to, and they're all smaller than the 2 with an or equal to. So -3 is less than X is less than or equal to 2. Let's look at okay, I think I must have meant something else by what I'm looking at in my notes here. Go back across the page again, back to those equations and inequalities and stuff. What would we do on number 9? 3 steps or 2 steps, depending on how you work it. Just talk through it real quick, Josh.
Make a positive 9.
Put a positive 9 on both sides. Then what?
And then,
How do I get rid of 10/3?
You multiply by 3.
Okay, you multiply by the 3 to get rid of the 3. Okay, then what? Both sides,
And then
good.
you divide by 10 on both.
Then you divide the 10 on both sides. Luana, did you think of another way to do it? We could add the 9 to both sides and then multiply both sides by 3/10, couldn't we? Multiply by the reciprocal. Because the 3/10 would cancel the 3's and the 10's all at one time. That's another option there you could have. What about number 10? What would we have to do first? Lana?
We have to
What's it called?
combine the distribute.
Distribute to get
18x -12.
There we go. All equal to the 5x plus 14. And remember, just by way of review, I got an x on both sides. You can't have an x on both sides of that equal sign. What do?
You subtract 5 from both sides.
Get rid of the little one. Always get rid of the little one. Sorry, Hayden. And so then we would solve from there, get the x by itself. Drop down to 13. What would we have to do on 13? I'm sorry? We're not solving these. We're talking through them. All right, number 13, what would we have to do, Josh?
The same thing as an equation.
So?
You divide by -5 on both sides.
And that'll give me y on this side. Of course, on the other side, it'll give me a -2, but
You have to flip it since
Right.
it's a negative.
flip the inequality since you divided by a negative. Not since you got a negative, but since you divided by a negative. Look at number 16. It's a compound inequality, Lana. What would we do to solve for x in number 16?
Don't you add 12 to
Both sides? There's 3 things.
both?
Add 12 to everything,
Yeah.
right? Just add 12 to everything, all 3 things. Add the 12 and that'll knock it out, the positive 12. What about 17, Josh? What would we have to do here?
Divide by -7 on all of the sides.
Right, stay with me real quick. Study hall, you can go. Divide everything by the -7, but remember, Lana, when we divide by a negative, we have to...
Swap the sign.
Right, so here we get a positive 2, of course. Here's just y, here's -7, but instead of a less than class,
It's a greater.
and instead of less than or equal to,
greater than equal to.
but as you look at that, on a number line, you wouldn't find a 2 and then later on -7. That's exactly backwards. So remember, on that, we'd have to flip the whole thing around again. Remember? So the -7 would have to come here. The y stays here, the 2 stays here, but the symbol stays here with the -7 and continues to point at the -7. Mouth still opens to the y. Do you remember that? Let me move this out of the way for you there. Remember that?
Yeah.
And then this mouth still opens to the 2. So, wanted to refresh your memory on that. Again, this is something we'll do in Algebra 1 a little bit more as well. All right, your homework for this evening is to do page 569. Page 569, the homework 1 through 22. Page 569, the homework, numbers 1 through 22. We'll take a look at those in our next lesson, your exam. if you're taking it, is in lesson 178. So this is lesson 174. Lesson 178 will be the final exam. Have a wonderful rest of your day.